Hi and welcome. In this video, we will see what is a derivative and what is a gradient. These are two basic constructs which are used in many machine learning algorithms like gradient descent, which is used in linear regression, neural networks, and many other machine learning algorithms. So let's get started and see what is a derivative. Simply put, derivative tells the slope of a function. So if the function is f, then the derivative of f is denoted as f prime or f dash, and this f dash could either be a function or it could be a constant value, as in it could be a function of another variable or it could be a value which is a constant, and the derivative describes how fast this function f grows or decreases. If the derivative f prime is a constant value, then the function grows or decreases constantly at any point x of its domain. Okay, so this f is a function of x, and even if we change the value of x, the slope of the function remains the same at all the points. On the other hand, if f prime is a function of x itself, then when we change the value of x, then the slope of this function changes with respect to x. If the derivative f prime is positive, that means the function grows at this point. If the derivative f prime is negative, that means the function reduces at that point. And if the derivative is 0, that means the function is horizontal. Because if the derivative is 0, that means the slope of the function is 0, and the slope of a horizontal line is always 0. Now, what exactly is differentiation? Differentiation is nothing but the process of finding a derivative. Now, how do we compute the derivative of a given function? So, firstly, there are some basic functions whose derivatives are known, and it will be nice if we keep these in mind so that we can quickly apply them. So, as an example, the derivative of x square is 2x, the derivative of x cube is 3x, the derivative of 3x is 3, and the derivative of 3 will be 0. And for that matter, the derivative of any constant value will be 0. So there are many other basic functions as well. You can take a look at them and you can keep them in mind. They'll be very handy in applying them to any machine learning algorithm. Now, in case the function is not a basic function, in that case, we can apply what is called a chain rule. Now, in that case, what happens is the function is not a basic function, rather it's a function of a basic function itself. For example, this function fx is a function of another function, that is gx. So in this case, what we do is we first compute the derivative of this outer function and then we multiply it with the derivative of the internal function. Let's take an example. So here this function fx is a function of 3x plus 2, right? So it's not a basic function like x square. It's itself a function of 3x plus 2. So here gx will be 3x plus 2. So what we do is we first compute the derivative of this function, assuming it is x square, and we know the derivative of x square is 2x. So this comes out to be 2 multiplied by 3x plus 2. And then we multiply it with the derivative of 3x plus 2. The derivative of 3x will be 3 and the derivative of 2, which is a constant, will be 0. So we overall we get 3. So we multiply these values and this is what we get. So this is how we compute the derivatives of the functions which are not of the basic form. Now let's see what a gradient is. Now so far we looked at functions which were functions of only one variable, as in this f was a function of x only. Now, let's say there is a function which is a function of more than one variables. For example, it's a function of x as well as y. Now, how do we find the derivative of such a function? So, in such cases, when the function is a function of more than one variables, we don't compute derivative, we compute what is called as gradient, which is also called partial derivatives. Okay. So, gradient is the generalization of derivative for functions on several variables. And gradient is always a vector of partial derivatives. So if there is a function on one variable and we compute the derivative, that is only one value. It will either be a function, another function, or it will be a value, but it will be one thing. On the other hand, gradient will be a vector which will have multiple values. If there are three variables, there will be three values in this vector, and so on. So, what exactly is partial derivative or gradient itself? Is the process of finding the derivative by focusing on one of the variables and considering the other variables to be constants. So what we do is, if there are say three variables, we compute the partial derivatives with respect to each of these variables, say x, y, z. When we consider x, when we focus on x, we consider that y and z are constants. And when we focus on y, we consider x and z to be constants. And similarly, when we focus on z, we consider x and y to be constants. So let's take an example. Here this function fxy is a function of x and y. So what we do is we compute first the partial derivative of this f with respect to x. And while we focus on this x, we consider y to be constant, and we know the derivative of constant is 0. So this is what we get. Similarly, then next we can compute the partial derivative of f with respect to y, and then we focus on y and we consider x to be a constant, which will have a 0 derivative. So this is what we get. So we get these two values, and these are pronounced as del f by del x. So derivative, if you pronounce derivative, that is df by dx. On the other hand, the gradient will be pronounced as del f by del x, and we put them in the form of a vector like this, and this is termed as delta f, right? So that's what is the gradient of a given function. And again, if the function is not basic, then we apply chain rule, as we did in the case of derivative. So this was a basic introduction to derivatives and gradients. In case of clarification, suggestions or criticism, you may please write on this email. Thank you.